So in section 5.6, we're going to continue factoring problems that have two terms. But instead of being squares like they were in the previous section, we're going to factor cubes. We're going to factor cubes with plus signs and cubes with minus signs. Cubes with plus signs we're going to call sums of cubes. Cubes with minus signs we're going to call difference of cubes. In section 5.5, the squares with minuses factored, the squares with pluses were prime. In section 5.6, both cubes will factor. So let me try to illustrate the kinds of problems that we're going to be asked to factor, the criteria where it will take to be one of the two categories. So the first category is difference of cubes. I have this disgustingly ugly formula. There's actually a formula to factor difference of cubes that will I'll wave my hands at a little bit, and I'll show you a strategy to factor that uses something equivalent to the formula that's not so complex. But anyways, before I can decide on whether I can factor it as a difference of cubes, I need to see if it's a difference of cubes, and if it is, then I can go ahead and attempt to factor it. So to be a difference of cubes, you can only have two terms, just like squares problems only had two terms. To be a difference of cubes, you have to have a minus between the terms. And to be a cube problem in general, your exponents for the variables have to be multiples of 3. I might see like x cubed, y to the 6th, z to the 9th, and so forth. And my numbers that I have listed there are all perfect cubes. For instance, 1 is equal to 1 cubed. So 1 is a perfect cube because it could be written as some number cubed. And 8 is equal to 2 cubed. If I do the cube root of a number and I get an integer, that's the number that is cubed that equals the bigger number. 27 is equal to 3 cubed. 64 is equal to 4 cubed, and so forth. Let me show you how to factor a difference of cubes by sneaking one of the homework problems. Right on the sheet, I'm going to do problem 4 and check it. So problem 4 is a difference of cubes, and I'll show you why it's a difference of cubes. I give you the problem. I asked you to factor y cubed minus 64. And when I look at this, does it meet the criteria that's necessary? Yes, it only has two terms. Yes, there's a minus between the terms. The exponent is 3, which is a multiple of 3. We're good with that. The numbers are perfect cubes. Yes, the only number 64 is 4 cubed. So it is a perfect cube. What I'm going to do now is get myself the template that's given to me and fill it up kind of logically rather than using the formula, because the formula is a lot to look at. So I'm going to fill in my parentheses with the signs from the template. The first parentheses gets 1 sign and 2 terms. The second parentheses gets 2 signs and 1 term. How to remember how to fill in the signs? The first parentheses gets the same sign that the problem has. This problem has a minus sign, so my first parentheses is going to get a minus sign. My second parentheses, the first sign in my second parentheses, is opposite of the sign that I just put in. I just put a minus sign in, and the sign opposite of a minus is a plus. And then the second parentheses, its second sign is always plus. So this is the template that I'm going to use to factor y cubed minus 64. I'm going to have one parenthesis that has a minus in front of it, in the middle of it, and the second parenthesis has a couple of pluses. To figure out what to fill in the first parentheses, I have to figure out what cubed equals y cubed and what cubed equals 64. For the y, to figure out what cubed equals y cubed, I'm just going to divide its exponent by 3, and that's going to give me y to the first. So I know that y cubed is equal to y times y times y. Next, I'm going to figure out what cubed is equal to 64 by going shift and square root for the cube root symbol, typing the number 64, and this tells me that 4 cubed is equal to 64. So 64 is equal to 4 times 4 times 4. In the first parentheses, I get 1 from each group. And that's one of the first items cubed, one of the second items cubed. This is exactly what the formula is telling me to do, but the formula is using, symbols that you might not be comfortable with. I wouldn't have been comfortable with those symbols in a algebra class if I was enrolled. My computer, every now and then it just spools up. I don't know why. Sorry, hopefully it's not making it so you can't hear me. Now that I have the signs in my second parentheses and my first parentheses completely filled, I'm going to form groups of 2 from the cubes that I created. And I'm going to shove them in order in the parentheses, the second parentheses. So to start off my second parentheses, I'm going to write a y times y, which is my first pair. The middle term in my second parentheses is going to be y times 4. The third term in my right parentheses is going to be 4 times 4. And that's actually what this says to do. This says square the first value, and that's multiplying it by itself. This says multiply 1 from each grouping, that's what I just did. And this says square the last, and that's technically what I did. I'm about ready to write an answer down, and I'll check it here in a second. So the first parentheses, I'm good. It's y minus 4. The only thing I'm good with right now are my signs in my second parentheses of plus and plus. I need to multiply the y times y that I filled in, and I'll get a y squared. Y times 4 are already multiplied, but I might write them as 4y. And I'll multiply the 4 times 4 and get 16. I claim that's the answer to number 4 if I was on the sheet that had number 4. I'd write it on that sheet, but I'm not. Let me show you how to check. To check is kind of ugly. It's some of the multiplication that we did in chapter 4, some of the ugly multiplication that we did. So to check, I'm going to do horizontal multiplication. I'm going to put the second factor on top of the first factor. The second factor is y squared plus 4y plus 16. The first factor is y minus 4. Put a times sign indicating that I'm multiplying. And now I'm going to go negative 4 times positive 16. Negative 4 times positive 16. And I'll get negative 64. And then I'll do negative 4 times positive 4y and get negative 16y. And then negative 4 times y squared and get negative 4y squared. Move down to the y and multiply it and start indented 1. I'm going to multiply the positive y times the positive 16 and get positive 16y. I'm going to multiply the positive y times the 4y and get positive 4y squared. And I'm going to multiply positive y times y squared and get positive y cubed. I'm going to bring down by minus 64. The 4y squareds and the 16y's cancel, and I'm going to bring down my y cubed. And what I have there with a big gap is y cubed minus 64. Because that equals the original problem, I know I've factored correctly. And it's always the case when I'm factoring with cubes that the second parenthesis is always prime. So factoring differences of cubes is messy, but after we do 4 or 5 of these, it won't seem so bad. The nice thing about cubes is It doesn't matter if they're a sum of cubes or a difference of cubes. They're both going to factor. And other than the signs that go in the parentheses, they factor exactly the same way. So if I presented with a problem in this section, if I want to try to identify it as a sum of cubes, I look to see if these factors happen. The problem only has two terms, a plus sign between the terms as opposed to the minus. Exponents are a multiple of 3 and numbers are a perfect cube. Same exact rules except for the plus sign. Problem 1 in our homework, this is a sum of cubes. The x has an exponent of 3, which is one of the acceptable exponents. The number is 8, which is an acceptable number. It has two terms and it has a plus sign between. So this is going to factor, and I'm going to use my same strategy to factor. I'm going to use the template to fill in my signs, or be clever. The first parentheses gets the same sign that the problem has. This problem has a plus sign, so my first parentheses is going to get a plus sign. My second parentheses has two signs. The first sign in the second parentheses is the opposite of the sign that I just plugged in the first parentheses. The opposite of plus is minus. And the second parentheses, second sign is always plus. So that's the template. We do same sign, opposite sign, and plus. First parentheses, second parentheses. And now I'm going to do exactly the same. The rest of the factoring is 100% the same. For the x cubed, I'm going to divide its exponent by 3 and get x to the first. So x cubed is equal to x times x times x. I'm going to cube root the 8. Shift and square root gives me the cube root. The cube root of 8 is 2. So this cube root of 8 tells me that 8 is 2 times 2 times 2. Now that I have my values that I'm going to need to fill up my parentheses, I fill them up exactly the same way. My first parentheses gets 1 from each group, which means 1 from the group of x's and 1 from the group of 2's. My second parentheses, I make pairs and I multiply. My first pair is going to be x times x. My second pair is going to be x times 2. My last pair is going to be 2 times 2. Let me clean up that parentheses and I'll get what I say is an answer for problem 1. So problem 1, it's going to factor into the product of x plus 2. And then second parentheses, x times x, I'll write an x squared. I'm keeping all the signs. The x times 2 I'll write as 2x, and the 2 times 2 I'll write as 4. I'll check it, and this will be the last problem I check. To check it, I'm going to do the horizontal multiplication. I'm going to write the x squared minus 2x plus 4 above the x plus 2, and I'll start and I'll multiply. So I'll put maybe a times sign. I'll go 2 times 4 is 8. 2 times minus 2x. 2 times 4 is 8. 2 times minus 2x is minus 4x. And 2 times x squared is positive 2x squared. I'll do the same with the x. I'll go x times 4 is positive 4x. I indent. And then x times minus 2x, which is minus 2x squared. And then x times x squared, which is x cubed. Bring down the 8. Cancel, cancel. Bring down the x cubed. I need a sign here, and because the 8 is positive, I'm going to put a plus sign. It's not worthy of a minus sign. If I look at the original problem and what my checking did, I know my answer is correct. So these are really ugly in terms of how they look, but eventually they're just not that bad to factor. We'll do a handful of problems, but not all 40. Let me do 6 to factor x cubed plus 125. I'm going to make my signs up first. First parentheses, I keep the sign. I put the same sign that the problem has. This problem has a plus sign, so I'm going to put a plus sign. Second parentheses, whichever sign that I put in the first parentheses, I'm going to put the opposite of that, which is minus. And the second sign in the second parentheses is always plus. Again, we do the SOP acronym, same opposite plus. Now to figure out what goes in the parentheses, the variable, I'm going to divide its exponent by 3. And that's going to tell me that x cubed can be written as x times x times x. I'm going to cube root 125. And I'll get 5. And that tells me that 125 can be written as 5 times 5 times 5. First parentheses, 1 from each of the groups. So I'm going to lead off the first parentheses from 1 from the group of x's, and off my first parentheses from 1 from the group of 5's. Second parentheses, I start making pairs. First pair is going to be x times x, and I'm just going to multiply those up front. The x times x pair will give me x squared. Second pair is x times 5. I'm going to multiply those and write those as 5x. Third pair, 5 times 5, that's 25. Second parentheses is always prime. If I wanted to check this, I do the vertical multiplication, but it takes so long to do it that I won't always check these. Let's do 11 together. You'll see that my numbers are very repetitive. I don't want the cubes to be so big, so you start to see lots of repetition and the problems start to look a lot alike. X cubed minus 64, it's going to classify as a difference of cubes. It has the minus, the exponent's a 3, it has 2 terms, and 64 is a perfect cube. I put my signs in. I keep the sign, flip the sign, and plus. Same opposite plus. Same sign as the problem. Change the sign that I put in the first parentheses to leave the second parentheses, and then plug plus. For me, knowing the x cubed is x times x times x, I don't need to do any special dividing. I just know that. And then the cube root of 64 is 4. So underneath the 64, I'm going to write 4 times 4 times 4. Now I'm going to fill this up. First parentheses gets 1 from each grouping. 1 from the group of x's, 1 from the group of 4's, in the order that you'd expect. And now fill in. Second parentheses leads off with x times x. Rather than writing x times x and taking an extra line to write x squared, I'm just going to multiply those. X times x is x squared. The next part of my second parentheses is going to be x times 4, which I'll just write as 4x. I'll end up my second parentheses with 4 times 4, which is 16. The beautiful thing about cubes is I don't have to worry about primes, and really the only thing I need to worry about is figuring out how to make them into cubes and getting the right signs. Let's do 15 so I don't overload you with homework. So 15 wants me to factor 8x cubed plus 27. 8 is a perfect cube. 27 is a perfect cube. And the letter has an exponent of 3. This is a sum of cubes. Let me put my signs in. Put the same sign that the problem has. This problem has a plus sign, so it's going to lead with a plus sign. Then whatever sign I just put in to fill up my second parentheses, I flip the sign. And then the second parentheses always ends with plus. Now I need to figure out what to plug in the first parentheses. I'm going to cube root the 8 and get a 2 and divide the exponent of the x by 3. I claim that 8x cubed is 2x times 2x times 2x, because if I was multiplying these, I'd multiply the 2's and I'd add the exponents on the x's. For the 27, I'll cube root it and write 27 as 3 times 3 times 3. Basically done now. First parentheses, 1 from each grouping, 1 from the group of 2x's, 1 from the group of 3's. Second parentheses, start making pairs. First pair is 2x times 2x. I'll multiply the 2's and multiply the x's and get 4x squared. Middle pair, 2x times 3 is 6x. Last pair, 3 times 3 is 9. That should be the answer for problem 15. Again, I'll steal some of your homework. I don't want to overwhelm you with homework, so let's do 19. So 19, signs are going to be keep the sign, flip the sign, plus. I'm going to cube root the 64 and get 4. Divide the exponent of the x by 3 and get x. My first piece is 4x times 4x times 4x. My second piece is y times y times y. First parentheses, 1 from each grouping. 1 of the 4x's, 1 of the y's. Second parentheses, I multiply the 4x times 4x and get 16x squared. Then I multiply the 4x and the y and just leave those written next to each other as 4xy. And then I end off with y times y, which is y squared. Second parentheses is always prime. On this sheet, I'm going to do 24 and let you do your problems. Hopefully 24 is representative enough that you can do 21. In fact, let me tell you what 21 is. 21, you divide the exponent by 3. So my starting is going to be x cubed, x cubed, x cubed, and y, and y. That's what you're going to need for filling up your templates. My problem 24 and your problem 23 are structurally the same. That's why they're listed next to each other. They have a common factor that I need to factor out. I'm going to factor out a 3 as my GCF. When I factor out a 3, I'm going to be left with an x to the 6th minus 27, which is going to be a cube with a minus, or a difference of cubes. So I'm going to fill up my signs, keep the sign, flip the sign, plus, same sign, change the sign, plus, and to fill up the parentheses, the exponent on the x I divide by 3. Underneath the x, I'm going to write x squared times x squared times x squared. I'm going to cube root the 27. And underneath the 27, I'm going to write 3 times 3 times 3. First parentheses gets 1 from each group. 1 of the x squareds and 1 of the 3's. Second parentheses, it would lead off with x squared times x squared. And then I'd add those exponents as opposed to multiply those exponents and get an x to the 4th. My middle pair is going to be x squared times 3, which I'll write as 3x squared. My last pair is going to be 3 times 3, which I'll write as 9. So for my second parentheses, which is always prime, in problem 24, I get x squared plus 3x plus 9. Let's snag one of your ugly problems, like 27. 27, there's a common factor. I need to factor it out first. It's the same common factor of 2. Because cubes are inherently large, I keep the common factor small. Anytime we're doing any kind of factoring problem, if there's a common factor, we should factor it out first. So I'm going to factor out my 2, divide the 16 by 2 and get 8, leave the x cubed, so the first term is 8x cubed, divide the 54 by 2 and get 27. The common factor of 2 is going to belong in my answer, but it's not going to impact how I create the 2 parentheses. And then I do my signs. Keep the sign from the problem. The sign that I plug in the first parentheses, I flip it, and then I put a plus in. I'm going to cube root the 8 and get 2. Divide the exponent of the x by 3 and get x to the first. The 8x cubed is 2x times 2x times 2x. The 27 is 3 times 3 times 3. One of the 2x's and one of the 3's go in my first parentheses. My second parenthesis starts with 2x times 2x. I multiply the 2's and get a 4. I multiply the x's and get an x squared. Then I do 2x times 3. And I get 6x, and then I do 3 times 3, and I get 9. Second parentheses, always prime, and that's the whole answer. Other than that, that doesn't look like a minus, it looks like an underline, but that's supposed to be a subtract. Maybe, 27 minutes, maybe 2 more? Gosh, I've got way more than 2 more, but maybe 3 more. Let me do 32. There's nothing new, there's just more volume. In 32, I'll pull out my common factor of a y. Both terms have a y. The smaller exponent is the y to the first, so I'm going to factor out the y. That y is going to be part of my answer, but it's not going to impact how I create the 2 parentheses. Throw my signs in, keep the sign, flip the sign plus. Underneath the y cubed, I write y times y times y. Underneath the 64, I put 4 times 4 times 4. The numbers get repetitive, so I stop having to use my calculator. First parentheses, 1 from each group. Second parentheses leads off with y times y, which is y squared. Then y times 4, which is 4y. And then 4 times 4, which is 16. All of these can be checked doing the horizontal multiplication, but it's not necessary. When I glanced at 35, I said, oh, there's got to be a common factor. The numbers are so big. And there is and there isn't a common factor. The 8 is a cube. The 125 is a cube. It's the exponents that need to be 3s, 6s, and 9s. There is a common factor in 35. The common factor is x squared. I'm going to factor out the common factor of x squared. From the first term, I'm leaving the 8. The first term had 5 x's. I got rid of 2 of them by factoring out. I'm left with 3 x's. I'm not changing any signs because I didn't factor out a negative. I didn't factor out a number, so I'm leaving the 125. And the x squared, I got rid of. I'm going to write my answer, leave myself some room. For my parentheses, I keep the sign. This first sign is plus, I'm going to keep it. Then whatever sign I plug in, the first parentheses, I flip. The last sign is always plus. So keep the sign, flip the sign plus, same opposite plus. Underneath the 8x cubed, I'm going to write 2x times 2x times 2x. And underneath the 125, I'm going to write 5 times 5 times 5. First parentheses, 1 from each group, so 1 of the 2x's and 1 of the 5's. Second parentheses leads off with 2x times 2x, which is 4x squared. Then it goes 2x times 5, which is 10x. And then it goes 5 times 5, which is 25. There are a few more problems, but there's absolutely, yes, there is. We should do a factoring out a negative before I quit. Let's do a factoring out a negative because that's an important skill. My template, or the formula, needs the first term to be positive. And in problem 38, there isn't a common factor, but the first term is negative. To get started, I'm going to factor out a -1. And when I factor out a -1, I switch signs. The positive y cubed, it will change to -y cubed. And the positive 64, I'll change to -64. The common factor of -1 is going to be in front of my answer, but it's not going to impact how I create the two parentheses. For the signs, I keep the sign, I change the sign, and then plus. Underneath the y cubed, I'm going to write y times y times y. And underneath the 64, I'm going to write 4 times 4 times 4. First parentheses, one of the y's, one of the 4's. Second parentheses, first pair is y times y, which is y squared. Second grouping is y times 4, which is 4y. Third grouping, 4 times 4, which is 16. Now I'll stop, even though we're pushing 32 minutes. I think we've done enough that it should hopefully not feel so bad. These are just very repetitive. It's the same thing over and over again. It's hardly different for a plus and a minus. It's just knowing how to break it up into cubes, and if there's common factors, getting the common factors factored out.